இது வருது பாஸ்வேர்டு கேட்காது.
Hi guys, are you able to hear me? Is everything fine?
Yes, sir.
Okay, fine. Let's start. Good morning. Right. So we have been seeing chemical kinetics, isn't it? Right. And we did some problems. We saw how to calculate the order and all those stuff, right? So we saw one method called as initial rate method, right? So hope you remember how the formula goes. So it depends on the initial concentration. So how do I put it? The rate R1 by R2 is equal to R01 divided by R02, the whole power n. So both the rates, these R01 and R02 are the initial concentrations, right? So if I know rate R1 and R2 and this R01 and R02, I'll be able to find what is the n value. That is the order. N is the order here, right? So we did all that, right? Okay. So we'll go for one more method now. Right? We'll go for one more method of. Actually, before that, I think it's better that you do some problem. Like I told you that we have to have that table kind of problems. I told you you will be getting it. Let's see that. Okay. So I have this reaction with me. I have 2A plus B giving C plus T. These are all. This is the reaction I have. Okay, and they have given me this table, right? So first is concentration of A, concentration of B, right, and the rate of the reaction, right? Okay, so like yeah, this goes like this: 0.1, 0.1, 6 into 10 to the power minus 3, 0.3, 0.2, 7.2 into 10 to the power minus 2, 0.3, 0.4, 2.88 into 10 to the power minus 1, and lastly 0.4, 0.1, 2.4 into 10 to the power minus 2. So yeah, so this data is given to you. You're getting a small glare. Just a minute, guys. So yeah, so this data is given to you, right? So I want you to find the rate law, right, as well as the k value, right? I want you to find what is the rate law equation, that is R is equal to k into a power, the power that is the order of A, order of B, as well as I want you to find what is the rate constant. Okay, so I'll give you 2-3 minutes. You try this problem. I already told you, I already gave you a say a model on how to work on this, right? So first I find me the rate law, then we'll speak about K. Now, how will you approach the problem, right? Say for example, right, if I have to find the order of B, for example, right? If at all I want to find the order of B, I will take two iterations. I will take any of these two steps, and if at all I want to find the value for B, I will make A constant. I will make A constant. For finding out the value of B, A will be constant. So you can see where, like in which two places A is constant. So you can look at here, 0.3 and 0.3, right? But the value of B is varying. So if I use this value and this value, that is second and third value, I will be able to get what is the order with respect to B. Same way, if I have to find the order with respect to A, right, I have to take two steps at a time, right? And I have to make sure that B is constant now because I'm finding out for A, so B should be constant. So where and all B or B is constant, first value and fourth value, 0.1, 0.1, the concentration you can see, right? But here the concentration is varying, 0.1 and 0.4. So I'll be able to find what is the order with respect to A. Do this. So basically I have to use this equation. R1 by R2 is equal to first initial concentration divided by second initial concentration power n. So if at all you will not take both A and B at the same time because anyways you are making one of them constant in both the values. So that particular concentration will get cancelled, right? Hope everyone is trying. Yes, any answers? Like today is Thursday only. This is 12th class. I'm not teaching you 11 concepts. Hopefully, and you're not at 11. I'm teaching you 12 concepts. Why is it so silent?
Sir, is n equal to 2?
There are two n values, one for A, one for B.
Alright, for A, I found it just for A. Yeah.
Okay, so for A, it is telling you're telling it's 2. Okay,
with respect to B, A is constant, and with respect to B,
okay, with respect to B, you're telling the order is 2. Okay, we'll check. You can try for A.
Okay, sir.
Yeah. See, this kind of problem, definitely you're getting 5 marks or 3 marks for sure. This table problem, you will definitely get in your board exam. I'm writing and giving it to you. Try this. It's very easy. I told you how to do it also.
Sir, I found with respect to A also, n is
What
equal
is
to
it?
1. 1.
1. Okay, fine. Cool. So we'll check this. Right. So hope you have the data with you. I'll just rub off this. Okay. So like let me find the order with respect to B first. Okay. So if at all I want to find order with respect to B, I have to take two instances, and in those two instances, A should be constant. If I'm finding for B, A should be constant. If I'm finding for A, B should be constant. So fine, let me find it for B. So I have to you can understand that you have to take the second and third values, right? So second and third value in both the things, the concentration of A is 0.3, right? But concentration of B is 0.2 and 0.4 in 2 and 3 respectively, right? So let me write the rate law. Say for the second value, right? For the second value, I can write R2. Just because it's second, I'm calling it as R2. R2 is equal to K into A power, that is 0.3 power some X, which I don't know. And for B, I have 0.2 power Y. Correct? Okay, so let me go for R3. Rate constant is same and A is same. And I have the value for B here to be 0.4 power Y. And I think I have my R1 and R2 values also, isn't it? So R1, R2 values also I'll fill here. So it's 7.2 into 10 to the power minus 2. And for this, it is 2 point, or I'll write it as 0.2. Okay, I'll write it as 10 power minus 1. I'll write as 10 power minus 2. So I'll write it as 28.8 into 10 to the power minus 2. I'll write it like this. It's actually 2.88 into the power minus 1. I wrote it as 28.8 into 10 to the power minus 2, just to make sure that 10 power 2 and 10 power minus 2 gets cancelled. Okay, so now what will I do? I will, so this is for 3, basically what I wrote here, right? So what you do is, you take the 3 value and divide it by the second value, right? You take the third equation and divide it by the second equation. So what will happen? So I will have 28.8 divided by 7.2, because 10 power 2, 10 power minus 2, 10 power minus 2, 10 power minus 2 gets cancelled. K gets cancelled. 0.3 power x, 0.3 power x gets cancelled, right? So now what do I have? I have basically 0.4 divided by 0.2, the whole power y, 0.4, 0.2, whole power y, right? Okay. So now this, can I approximately say that, no, not even approximately. So this is basically 4 times 7. 7.2 into 4 will become 24.8. So this is 4. So 0.4 divided by 0.2 will become 2 power y. So 2 power y is 4. So what should be y?
2.
Correct. So 2 power 2, that is 2 squared is only 4, right? So y here should be 2. Yes, your answer is correct. Okay, whatever told me the answer. So understood how we are doing it. I took the second and third, right? In that A is constant, right? So I was able to cancel K and I mean the 0.3 power x and 0.3 power x, and I was able to divide the third equation by second equation, and I got the y value, that is order with respect to B, as 2. Done. Same way I'll be able to do for A also, right? Please take this down first. I don't have space, and I can go for A. So now if I have to find A, I have to make sure that the B is constant, right? So where and all B is constant, in the first and the fourth datas, B is constant, 0.1 and 0.1, but the A is varying, 0.1 and 0.4, right? So now I'll take the first and fourth data and then I do the exact same thing, but instead of finding Y, I would have found X. That's it. So we'll do that. Wait. Okay. So if I take the first data, I have R, that is R value is 6 into 10 to the power minus 3 is equal to K into A power X. So A is 0.1 power X, and into 0.1, that is concentration of B, or y. Anyways, I have found out y. You can put the value or don't put the value. Anyways, it's going to get cancelled. So no problem. Okay. Fine. So that is my first. And if I go for my fourth data, so they have given R value is 2.42 into 10 to the power minus 2. So if I write it as 240 into 10 to the power minus 3. Oh, it's 24, sorry. So it's actually the given value is 2.4 into 10 to the power minus 2. So since I have 10 power minus 3 here, I'll write it as 24 into 10 to the power minus 3. Okay, I just changed the tens powers, right? Again, k into the value for a is 0.4 power x. And here I have 0.1 power y, right? Now what I can do, I can divide these two equations. So I will divide 4 divided by 1, right? So what do I have? 24 divided by 6 is equal to 10 power gets cancelled, kk gets cancelled, 0.1 power y gets cancelled. So what I'm left with is 0.4 divided by 0.1, the whole power x. So this basically will become 4 power x, and 24 by 4. 24 by 6 will become 4. So 4 is equal to 4 power x. So definitely x should be what? 1. 4 power 1 only is 4, right? That's it. Now I got the answer. Almost I got the first part of the answer. I got the rate law, isn't it? So what is the rate law now? R is equal to k into a power. What is the power? What is the order with respect to a? 1 into b power 2. Because y I found as 2. That's it. This is the answer. This is the rate law for this particular question, right? Everybody understood? Please give me a yes, guys.
Yes, sir.
What about others? There are so many people here. Everybody understood?
Yes.
Understood, sir.
Okay. Still getting only minority number of answers. Hope you understand. Okay, fine. So this is the answer for this question. Hope you know how you did it, right? Fine. So last step is that I have to find this k value also, basically. Now this k value I have to find. Now it's very simple. I can take any one of the data. I have 4 data with me, right? I can have any one of the data because R value is given, A value is given, B value is given, and I know the orders also, right? R value is given, K value is given, B value is given, and their orders also I know. I found out now. So it's very easy for me to find the K value, isn't it? Right? So that we'll do. Okay, so I can take any one of the. I can take any one of the. Let's say I take the first data, right? So in the first data, I have R is equal to what? R is equal to 6 into 10 to the power minus 3 is equal. I'm taking the first data, right? 6 into 10 to the power minus 3 is equal to K value, which I have to find. A value is 0.1 power 1. I saw the power is 1. I found out into 0.1 power 2. This is what I have, right? So if I can write this 0.1 as 10 power minus 1, it is going to become a little easy. Hope you understand why. Because 10 power minus 3 and 10 power minus 3 will get cancelled, isn't it? So I have 6 into 10 to the power minus 3 is equal to k 10 power minus 1. Here is 10 power minus 2 will become 10 power minus 3, 10 power minus 3. So k value is 6. Whatever now the order is 3, so you have to write the unit accordingly, right? So hope you remember. How do you remember the unit for k? Right, so unit of k. What is the formula? Unit of k, I gave you a general formula to remember. What is the formula? Nobody remembers. Okay, I don't know whether I gave or not. You tell me whether I gave or not. This is the thing. So it will be mole power 1 minus n, liter power n minus 1 per second, where n is the overall order of the reaction. Where n is the overall order of the reaction. Do you know how this is derived? It's very simple. right? So I have R is equal to Ka power n, right? R is mole per liter per second. And I know for concentration it is mole per liter, and I have a power n also. So I bring it this side. So this is what you'll end up with, right? Mole power 1 minus n, liter power n minus 1 per second, where n is the overall order. What is the overall order here? 2 plus 1, 3. Order with respect to A is 1, order with respect to B is 2. So the overall order is 3. So you have to put the n value as 3. So if I put the n value as 3, I will be getting 1 minus 3 will become minus 2. So it's mole per squared. 3 minus 1 will become 2. So it's liter squared per 1. So what is the answer? K is equal to 6 per mole squared, liter squared, liter second power minus 1. This is the answer. This is how you have to write the answer for this question, right? And obviously I'll be able to write the rate law in terms of K. So it's very simple. R is equal to 6, that is the K value, into A power 1 into B power 2. This is how you write the rate law. Okay, so you understand, hope you understand why this is given in 3 marks, right? It involves a little bit of calculation, but it's the most easiest question from which you can extract 3 marks just like that, right? So you have to practice a lot. Right? You want to do one more problem like this?
Yes, sir.
Yes,
Okay.
sir.
So this time, if nobody is answering, I think I have to reduce the number of problems, because I think nobody is trying. Like, I'm getting only few answers. Right? I'm getting bored. That is the main reason. Okay, just because I'm getting bored. Okay, see this one more question. Okay, this is a nice question. Looks like a nice question. Okay. So I have this reaction. 2NO plus Cl2 gives 2NOCl. So say first the experiment number, concentration of NO, concentration of Cl2, and lastly the rate. Right? Okay, so here experiment number 1, 0.15, 0.15. Here it is 0.6. Experiment number 2 is 0.15, 0.30. Here it is 1.20. Third experiment 0.30, 0.15. Here it is 2.4. And for the fourth experiment, it is 0.25, 0.25. And they're asking what will be the rate at this. So you have to find 3 things. First, what is the rate law? And you obviously have to find the rate constant and this value. 3 things you have to find. In the experiment number 4, find the rate of this reaction. Do it quickly. Don't have much time. You know how to do it. So basically, you cannot use the fourth value for now, right? You have to use only the first 3 values to find out the rate law and the K value also, right? And then using all this, now after you find the rate law, you know K value, you know the powers. Just put these values, K value also, you know, find the rate for the fourth one. Do it. Go for it.
Sir,
Yeah.
does the rate law with respect to Cl2 is 1?
Oh, you're telling me for Cl2 the order is 1?
Yes.
Okay, we'll check that. I'm not sure. We'll check.
Okay,
I'll do the
sir.
problem. You do for NO. Guys, at least for some of you, this chapter would have gotten over in school, no? For how many of you it got over?
Our school.
Sorry?
Yeah, our
What?
school teacher finished it off at school.
Okay. How about others?
No, sir, it didn't
Not
start.
for us.
They didn't start. Okay, how about the other chapters? I finished solutions and electrochemistry. Those two
Solutions completed, sir. Electrochemistry they are doing.
they are doing. Okay, so guys, are you finding it easier after attending class here and listening there?
Yes,
Are you
sir.
finding it
Yes,
easier?
sir.
Yes, sir.
Yes, sir.
So basically, my method of teaching is entirely different. Right? I don't teach you for marks. I don't teach you for anything else. I want you to learn chemistry as such because I love the subject. Right? So I will make sure that you love the subject also. That's the motto. And eventually, marks will come, isn't it? If you do something which you like, right, eventually benefits will follow. That's the motto I have. Yes. Any answers? Okay. If surprisingly, if I ask Gabriel, 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 are you there? Okay, fine. Right. So let me ask Sham, are you there? Shyam, okay. Tarun, Tarun. Oh, Gabriel is texting something. What happened? Yeah, Gabriel you will not be able to speak. So what I'm telling is, that I just actually there's no reason why I called. Actually, there's a reason. So out of nowhere, if I ask you to turn on the video, right, and I ask you to show your notes, will it be good? No, not for me. Like, will it be good for you? Hmm?
I think it's okay, sir.
Yes, sir. We are writing notes.
Okay, hopefully. Big C, please don't think like I'm doubting you or something. But the thing is, I really don't know what exactly is happening. That you're sitting in your homes, right? I'm not able to see. I will be able to see you, but it will not be that good while teaching, like showing your faces also. So please make sure that whatever comes out of my mouth, it's actually very valuable. Like not like value in the form of money. So like if at all you take it on your notes, it's going to be really easy for you. That's how it is, right? So please make sure whatever comes out of my mouth, whatever I write on the board is there on your notebooks, right? Or I have to do something only, like I have to ask you to behave like a school teacher, right? So ask you to send that whatever the notes you took into the WhatsApp, right? That's what I'm in the same group also now, like very wonderful. Okay. Fine, any answers? This much time it should not be taken.
So the rate value for the last fourth one is 2.77.
Okay, you found out all the other things, K value, the order with respect to
I'm not completely sure about the K value, sir, but I think the rate I got is 2.77.
Okay, what is the order with respect to NO?
2.
Okay, we'll check now. Fine. So hope you have the data with you. I will rub it off. I'll do the problem. Okay. So let me find the order first for Cl2. Right. So what I have to do? I have to make sure that NO is constant. Correct. So I have to take for where and all I say NO is constant. So I can see that if I take the first and the second equation, that is if I take the first experiment and the second experiment, the concentration of NO in both the cases is 0.15. So that I'll take, and obviously I have to make sure that Cl2 is varying. It is varying 0.5 and 0.3, right? So first I have R. Okay, R value is there, so I can write. So it is 0.6 is equal to K into NO power. Okay, NO is basically how much? Yeah.
Sir, your video is stuck, sir.
Video struck. 1 second.
Yeah.
Now is it okay?
Oh, yeah, sir. Yeah.
Okay, fine. Good. So I have 0.6 is equal to K into how much power X? 0.15 power X. And Cl2's concentration is 0.15 power Y. Cool. This is the first experiment. Second experiment, I have R is how much? 1.2 is equal to K value into again 0.15 power X. And for Cl2's concentration, it is 0.3 power Y. Okay. So what will I do? I'll divide 2 divided by 1. So what will happen? So I have 1.2 divided by 0.6. K gets cancelled. 0.15 power X, 0.15 power X gets cancelled. So what I have is I have 0.3 divided by 0.15 power Y. So obviously, what will you get here? You will get 2 is equal to 2 power X. 0.12 divided by 0.6 is 2. 0.3 divided by 0.15 is also 2. So I have 2 is equal to 2 power X. So obviously, I'll find X value as 1. Because 2 power 1 is what is 2.
Sir, it's Y value.
Oh, yeah. Thank you. Thank you so much. It's Y value. Good. Yeah. 2 power Y is 2. So Y is 1. Right. So this is for your, what is that? Order with respect to Cl2. Right. Now we'll go for finding the order with respect to NO. So I have to make sure that Cl2 is constant. So I have to make sure that I take first and the third experiment, because in first and third experiment, the concentrations of Cl2 is 0.15 and 0.15. And obviously the concentration of NO is varying to 0.5 to 0.3, right? So it's done, right? So now I can go for the next. So I'll take the first again. The first is 0.6 is equal to K into 0.15 power X into 0.15 power Y. Y again I found out, but it is not necessary. And for the third experiment, it is R value is 2.4, which is equal to K into 0.3 power X into 0.15 power Y. So I divide 3 divided 3 and 1. So KK gets cancelled. 0.15 power 1, 0.15 power 1. Sorry, power Y gets cancelled. So I have 2.4 divided by 0.6 is equal to 0.3 divided by 0.15, the whole power x. So you'll get 2.4 divided by 0.6 is 4, 0.3 divided by 0.15 is 2. So 4 is equal to 2 power x. So 2 power 2 is what is 4. So x here is 2. So y is 1. That is order with respect to Cl2 is 1. Order with respect to NO is 2. Done. So you answer the first question. We got the rate law. What is the rate law? I can easily write this. So R is equal to K into NO power 2 into Cl2 power 1. This would have been the rate law. Right? But that is not it. I have to find the K value also. I have asked you to find the rate constant. So I can take any one of the experiments. I can take any one of the experiment other than the fourth one, obviously, because I don't know the rate there. So any one of the first 3 experiments, and I will be able to find what is the K value, right? So that we'll try to do now. So let me take the first experiment itself, right? So first experiment, I have R value is 0.6, K value into 0.15 power 2 into 0.15 power 1, right? Okay, so 0.6 is equal to, so 0.15 the whole cube. So 0.15 squared will become 165. Basically, it will become 1.65. So 1.65 into 15.
225.
Yes, 225.
2.2.
Oh, okay. So it's 2.25, correct. 15 into 15 is 225, correct. So it will be 2.25 into 0.5. Actually, I can do it in 15 tables itself. So 15 5s are 75. 7, 15 2s are 30, 37. Okay, 37. 3, so 30, 33. So how many? 1, 2, 3, 4. 0.3375. Is it correct? 2.25. Yeah, correct. So here 2 points, here 2 points, totally 4 points. So it is.
Sir, if we square 0.15, then we will get 0.025, no, sir?
Oh, 4 things are there. Okay, so it is 0.0025. Correct. It's actually 0025. 0225. This is the answer. So this is 0.15 into 0.15. 4 decimals I have to keep. So 225, 15 into 15. So 4 decimals will become 0.025. So now this also should be 0.0033325. 275. Okay. Right. So now I'll be able to find the K value. So approximately I should not do. Right. So you can do the calculations later. So K value is 0.6 divided by 0.03375. Right. Okay. That's it. So I found the K value also. Now only one last thing I have to find. I have to find in the fourth experiment, what is the constant, what is the rate value, right? In the fourth experiment, I have to find what is the rate value. Correct. Easy now. I know the K value, I know the concentrations value, I know the orders, everything I know, just rate I have to find. So R in the fourth experiment, R4 is equal to, K value is this, that is 0.6 divided by 0.03375 into NO power 2, NO's concentration is 0.25.
Actually, it's 0.003375.
0.0.
Sir?
What I tell you? Yeah.
Sir,
Yes,
instead of calculating or multiplying, we can just keep it as 0.15 the whole cube, sir. Because
Okay.
when you have in the third equation, we have fourth equation. You will be having
actually
0.25
0.
the whole cube.
Okay, I
So it gets
understand. No,
easily
actually, instead of
calculated.
calculating this, I'll be able to cancel 0.15 and 0.6. No, that's actually a better way. So here, if I calculate, so 0.15 and 0.6 will go 4 times. Right?
Yes,
So this
sir.
is the better thing, right? So I'll be able to write this particular thing. Ouch, 1 second. So I can have it as 4 divided by 0.0225 is equal to K. Now this calculation is little easy, right? Okay. So anyways, you can do the calculation however you want it, however you want to make it easy, right? 0.25 squared into 0.25 power 1. That's it. So anyways, I think you can do the calculation by yourself, right? So just have to find the R value. Everything is known. Okay, fine. Good
Can
question.
you tell us the answer?
Yeah, sure. I will tell the answer once. This is okay. So the answer is 2.781 mole
But
per
2.7
liter.
is also fine, no, sir.
2.75 or
7, sir.
yeah, 2.77. But make sure that you have 3 decimals whenever you're going for calculations, at least in your boards, right? So make sure that you have after decimal 3 numbers are there.
Okay, sir.
Okay. So answer 7.7, 2.77 is actually correct, but make sure you have 1 more decimal. That's it. Okay. So done. That's about the problem. Okay. Cool. Right. So now we'll go for, what is the time? Okay, we have 15 more minutes. Okay. So now we'll go for one more method, right? One more method of finding out the order of the reaction, right? So even though it is, I don't know whether you will be asked in your board exams, but still it's very simple one. So I'll just give you a formula, right, to find out the order with respect to a special thing that we're going to learn now. So we are going for the next method of finding this thing, order, that's called half-life method. It's called half-life method, right? So first you have to understand what do you mean by half-life, right? So this half-life of this basically talks. This is for particular elements or compounds, right? So it's actually for different species at a particular condition. That's how half-life is actually defined, right? So this is how we're gonna define it. Take down the definition. So it's also represented by this thing T half, or I can even write it as T 50%, right? So all these represents the half-life period, right? T half, right, or say T 50%, right? So all these things are the representations of T half, half-life, right? So please take down the definition first, and then we'll see what is the method about it. I'm telling you the definition for half-life. Okay. Take down. It is the time taken for the reaction. It is the time taken for the reaction. It is the time taken for the reaction to get 50% completed. To get 50% completed. It is the time taken for the reaction to get 50% completed. Okay. Now looking at this statement, if I ask you this question, so how many half-lives are required for the completion of reaction?
2.
Okay, that's what we think, isn't it? But that's not how half-life works. Okay. So generally we say that time taken 50% is some time.
Infinite
right?
numbers.
Yeah, actually it is infinity. Ideally speaking, yes, it is infinity. Okay. So anyways, we'll see how that works. So please understand that it is not like in 2 half-lives, your reaction is going to get over. No, that's not how the half-life works, right? So it works like this, okay? Say assume that I have a reaction, right? Say assume that I have the reactant is converting into products, okay? So initially I say I have 100% of, okay, say I initially I have 100% of the reactant present. Right, the reactant has not reacted yet. Right, I have in the initial time t is equal to 0, right? So you have all the reactant concentration to be intact. The reaction has not started yet, right? So after 1 t half, right? After 1 t half, that is 1 half life, right? So this 100%, in this 50% would have reacted. So how much will be remaining? So 50% has reacted. So how much will be remaining? Only 50% of the reactant is remaining. Like 50% of reactant is remaining. Now again I go for one more t half, one more half life. Now what will happen? Another 50% will get over, but 50% of what? 50% of this 50%. So what will be remaining? Only 25% of reactant is remaining. Same way, another t half. Now 50% of this. Now that will be 12.5% of reactant is remaining. One more t half. So now this will become, I think, 6.25% of the reactant is remaining. So like this, I can have actually infinite number of t halves for reaction to get completed, right? So it is not like in 2 t halves the reaction is over. It is never ever like that, right? So please do not do that mistake, right? So for initially what I have, first t half 50% is over, and now the initial concentration is this, right? So after the second t half, 50% of this will be remaining. Again, after the second, next one, 50% of this would be remaining. After that, 50% of this would be remaining, right? So this is how t half works. Okay, fine. So again, obviously t half is actually an indication of actually how fast the reaction occurs, isn't it? Right? And this t half is also used for determining the stability, right? So for example, if I go for your radioactive elements, like say uranium, polonium, thorium, right? So cesium, right? So all these are actually radioactive elements, right? So for these elements, right, their half-life period is very less. For example, for your cesium, right, the half-life period is almost like an hour, like in 1 hour. Not even an hour, I think it's lesser than that. It's 30 minutes or 20 minutes. I'm not sure that, but actually it's a very less value. That means what? Say if I have 1 gram of cesium, right, initially, right, after some 20 minutes, if you see, only 0.5 grams of cesium would be there. What would have happened to the rest one? It would have gotten disintegrated. It would have reacted. It would have undergone the radioactive decay, right? And for 0.5 grams of that would have been gone, right? So basically t half, if I know t half, I'll be able to know how much time that particular compound will stay, at least approximately. What is the stability of that particular compound? Will it stay for a longer time, right? So all those things can be calculated if I know t half, right? That is the thing. Okay, fine. So using this t half, right, I will be able to, I'm telling you that we're looking at how to find the order of the reaction, right? So using this half-life period, t half, I'll be able to find what is the order of the reaction, right? So there is actually derivation for this, but it is not required for you. I'm going to give you directly the formula, how it works, right? So this is how the formula goes. So R naught, okay, write as. So again, you're going to do 2 experiments, right? In the first experiment. So obviously, please understand this. My half-life period is actually going to depend upon how much initial concentration I have. Is it not? Say if I have 100 m, 100 moles per liter, right? And say in the second case, I have only 50 moles per liter, right? So definitely in the second case, the reaction would have become faster. Right, basically, what I would say in the sense, the 50% completion would have become easier. Sir, what is the use of having half-life even in radioactive decay? So basically, you have to store all these elements, no, Kana, right? So basically, you have to store uranium, you have to store all these radioactive elements, right? So if I know what are these half-life period, accordingly, I will be able to give some conditions such that they will be able to improve their half-life. They'll be able to stay for a little more longer, so that I'll be able to store them for a longer time. That is how t half is used. Actually, t half is also used in archaeology, right? You know what archaeology is. Basically, they will excavate the grounds to find the historic civilizations and all that. All these things they find out. So there also T-half is used actually. There's something called as carbon dating, right? So there's something called as carbon dating. So carbon dating is actually a method to find out, say if I have a coin, for example, under the ground, when I excavated, I found a coin, right? So with the help of this carbon dating and this half-life period, I'll be able to measure how long, for how long it has been inside the ground. It belongs to which century? Say it belongs to 550 AC, or say it belongs to the year of 1500 years ago. All that they're able to tell, right? They're able to tell this dinosaur bone I found out, right, was approximately, they lived around 1.5 million years. All this they say with the help of this T-half and carbon dating only, right? So if you're interested, right, you can actually know more about this carbon dating. It's pretty easy only. It depends on this radioactive decay. So we'll be using the one isotope of carbon. I know carbon is having atomic mass of 12, right? So there I'll be using carbon with an atomic mass of 13. So I go for the isotope of carbon. So again, that will be actually depleting, right? So basically what happens is every living cell or every matter, I would say, right? Everything which is getting decomposed, everything is under the ground, will have some amount of carbon-13 isotope, right? Will have some amount of carbon-13 isotope. So basically for a living being, right? For a living being, the amount of carbon-13 isotope is some number, right? So when people die, right? When people die, that amount of carbon-13 from our body little keeps on disintegrating, right? Keeps on disintegrating. So like now, if I can find how much carbon-13 is there in that particular material which I found out in the excavation, right, I will be able to compare it with the value for a normal life, that is for a living being. I'll be able to compare the amount of carbon-13 in my body and the amount of carbon-13 in that particular substance which I found out, right? And I'll be able to compare and tell how many years it has been under the ground or how many years it has been dead. All those can be told. That is how it is actually done. Okay. So anyways, so half-life has actually so many applications. Okay. So anyway, so we are going to see how we are going to find out the half-life. I mean, how we are going to find out the order with respect to the half-life. So I already told you, right? If I have huge numbers, if I have high amount of reactant, right? Obviously the T-half will be little different. So if I have different initial concentrations, I will have different T-halves. That's what you need to understand, right? So depending on that, so I'm going to have this equation coming: T-half of the first experiment divided by T-half of the second experiment is equal to R naught of first experiment divided by R naught of second experiment, the whole power 1 minus n, where this n is the order. Where this n is the order of the reaction. Okay, so T-half of the first experiment divided by T-half of the second experiment is equal to R naught, that is the initial concentration of the first, divided by initial concentration of second, the whole power 1 minus n. Or you can write R naught of 2 divided by R naught of 1 power n minus 1. That is also, anything is fine. This is the mathematics. So now if I know the first two T-halves and if I know the initial concentrations, I'll be able to find the n value. That is the overall order of the reaction. But only one thing. The thing is, this will not work for first order reactions, right? This particular thing, whatever you're seeing, right, will not work for first order reaction. Basically, when n is equal to 1, when n is equal to 1, this will not work. For all the other values, it will work, right? Please make a note of it, right? So this particular method, whatever I'm seeing here, right, will not work for first order reactions. All the other values of n, it works. Okay, so you want to do a quick problem on this? It's very simple. I just quickly, what is the time? Time. Okay, we have 2-3 minutes. Quickly we'll do. Okay, take down this question. Right. For a reaction, A giving B for a reaction A giving B when concentration of A was changed from when concentration of A brackets A was changed from 0.502 mole per liter, changed from 0.502 mole per liter to 1.004 mole per liter to 1.04004 mole per liter. The half-life changed from 52 seconds to 26 seconds. The half-life changed from 52 seconds to 26 seconds. Right, they're asking you find the order of the reaction. Find the order of the reaction. So again, I repeat the question. For reaction A giving B, when the concentration of A was changed from 0.502 so when the concentration of A was changed from 0.502 mole per liter to 1.004 mole per liter, the half-life changed from 52 seconds to 26 seconds. Right? Find the order of the reaction. That's it. Just use this formula.
So 1 second. Can you
Your
repeat
voice is
the
breaking.
last part
Yeah.
on the half-life?
Okay. So the half-life changed from 52 seconds to 26 seconds. The half-life changed from 52 seconds to 26 seconds. Find the order of the reaction.
The NS2.
I think it's correct. So we'll check it. Right, so that's the formula. So what is the first T half? First T half is 52. Second T half is 26, which is equal to the initial concentration was 0.502 and the concentration was changed from 1.004 the whole power 1 minus n, or I'll be able to write this as 1.004 divided by 0.502 the whole power n minus 1. Now this value is equal to 2. 52 divided by 26 is 2. And this value is also 2 power n minus 1. Right? Okay. So now 2 is equal to 2 power n minus 1. So can I say n minus 1 should be equal to 1 because 2 power 1 is only 2. Right? 2 power 1 is only 2. So n minus 1 is 1. So n is equal to 2. Yes, your answer is correct. Right? N is equal to 2 is the answer.
Yes.
Just the formula substitution. What happened? Okay. Fine. So that's it, guys. So these are the methods by which I'll be able to find the orders of the reaction, right? Next class, you will be concentrating specifically on something called as zeroth order reactions and first order reactions, right? Basically, when I'm going to see about reactions where the overall order is 0, I'm going to have some mathematical relations derived, right? And for first order reaction, you're going to do the same. You're going to derive some mathematical relationships, right? And you're going to see some graphs, and then you're going to do some problems. All will do. Okay. So until then, we'll see. Bye bye. Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.